So in this video, I'm going to be going over the Chapter 4 review. The first question, the first few questions, I believe it's 10, nope. First 11 questions in this review are going over multiple choice questions. So the first one is asking, when we take a census, where are we attempting to collect data from? Remember, census is everyone, so my answer for this question is every individual in the population. Think of the 2020 census that just happened last year. They went around trying to get information from every single house in the U.S. Number 2 says you want to take a simple random sample of 50 of the 816 students who live in a dormitory on campus. You label the students 001 to 816 in alphabetical order. In the table of random digits, you read the entries, and then it lists this table for us. The reason we would do it 0001 to 001 to 816 is because I need the 3 digits to match. So when I go to break up my random digits, I'm going to break them up into groups of 3. So my first number is 955. This is larger than the 816 students that I have, so I am going to skip this number. Moving on, the next number I have is 929. Again, it's larger, so I want to skip. My next one is 400. I want to select 400. The next one is 769. This is in my range of 1 to 816, so I'll select it. Then I go again, and I get another 769. Because I have already written 769, I will skip the second one. I want unique numbers when I do this. Then my next number is 335. 335. This one is in my range, so I'm going to select it. So the 3 numbers I was selecting are 400, 769, and 335. So that is answer E. My next question says a study of treatments for angina, which is pain due to low blood supply to the heart, compared bypass surgery, angioplasty, and use of drugs. The study looked at the medical records of thousands of angina patients whose doctors had chosen one of these treatments. It found that the average survival time of patients given the drugs was the highest. What can you conclude? So notice, this is an observation. Because they are not assigning patients to treatments. They are just seeing what happened after the fact. So, I can't prove that they should be the lifelong drug. I can't prove that they prolong life and they should be the treatment of choice. I can't say that it's a comparative experiment because it's observational, so it's not even an experiment at all. I don't think the patients were volunteers because it didn't specify that they were. D says we can't conclude that the drugs prolong life because the group might differ in ways besides treatment. This is the answer here. I don't know anything about these patients, so I don't know if the reason they were given drugs over surgery was because they were more likely to survive and they needed emergency surgery. So if I'm only looking at the results, I can't say for sure if other things didn't lead to that. Number 4 says Tanya wanted to estimate the average of time that students at her school spent on Facebook each day. She gets an alphabetical roster of students in the school from the registrar's office and numbers the students from 1 to 1,137. Then Tanya uses a random number generator to pick 30 distinct labels from 1 to 1,137. She surveys 30 of those students about their Facebook use. Tanya's sample is a simple random sample because our choices are it was selected using a chance process. It gave every individual the same chance to be selected. C, it gave every possible sample size of 30 an equal chance to be selected. D, it doesn't involve strata or clusters. Or E, it's guaranteed to be representative of the population. This one is because we're looking and we can pick the groups, any way we do it, our 30 groups will be selected the same way. It could randomly be all juniors for all we know. So this is going to be our answer here, C. So moving on. Number 5 says to consider an experiment to investigate the effectiveness of different insecticides in controlling pests and their impact on the productivity of tomato plants. What is the best reason for randomly assigning treatments levels, so spraying or not spraying, to the experimental units, which it tells us are farms? A, random assignment eliminates the effects of other variables like soil fertility. B, random assignment eliminates the chance variation in the responses. C, random assignment allows researchers to generalize conclusions about the effectiveness of the insecticides to all farms. D, random assignment will tend to average out all other uncontrolled factors such as soil fertility, so they are not confounded with the treatment effects. E, random assignment helps avoid bias due to the placebo effect. So it's not E because the plants don't know whether or not they're getting insecticide. It is actually D because random assignment will average out other controlled factors, and so they're not confounded. Remember, when you're picking answers on the AP test and in tests in here in general, you want to make sure you go for the most precise answer. The next one says that researchers randomly selected 1,700 people from Canada who had never suffered from a heart attack and rated the happiness of each person. 10 years later, the researchers followed up with each person and found that the people who were initially rated as happy were less likely to have heart problems. Which of the following is most appropriate conclusion based on this study? Remember, this is an observational study. They didn't actually tell the people to be happy or not and like do things to improve their happiness. They just check in and observe. So A is happiness causes better heart health for all people. B, happiness causes better heart health for Canadians. C is happiness causes better heart health for the 1,700 people in the study. D is happier people in Canada are less likely to have heart attacks. And E, happier people in the study were less likely to have heart problems. So, I need to look at this. Were the people randomly selected? And were they randomly assigned? They were randomly selected, but they were not randomly assigned to be happy or not. So because of that, I can only say that the people in this specific study were less likely to have heart problems. Number 7 says a TV station wishes to obtain information on the TV viewing habits in its market area. The market area contains one city of population 170,000, another city of 70,000, and 4 towns of about 5,000 residents each. The station suspects that the viewing habits may be different in larger and smaller cities and in the rural areas. Which of the following sampling designs would yield the type of information the station requires? A stratified sample from the cities and towns in the market area. B, a cluster sample using the cities and towns as cities. Yeah, using the towns as cities. C, convenient sample from the market area. D, a simple random sample from the market area. E, an online poll that invites all people from the cities and towns in the market area to participate. So this one, E, voluntary response is almost never a good way to do it. Online poll is a voluntary response, so not a good choice. If I do a simple random sample, I might accidentally get too many people from the one city with the largest population because there's more of those people, or in general just because of the randomness of it. A convenient sample would probably mean I drive out to the closest city and ask everyone there. Also not a good idea because it's just one city out of the 6 viewing areas. A cluster sample is a bad idea because if I'm going to use a cluster sample, I'm going to pick one of my 6 places and then only get opinions about them. So my best choice is a stratified sample from the cities and towns in the market area. This one is a good choice because then I get a little bit of everyone from each of the 6 places. Okay. Number 8 says bias in a sampling method is any difference between the sample result and the truth about the population. B, the difference between the sample result and the truth about the population due to using chance to select a sample. C, any difference between the sample result and the truth about the population due to practical difficulties such as contacting the subject selected. E, any difference between the sample result and the truth about the population that tends to occur in the same direction whenever you are using this sampling method. E, racism or sexism on the part of those who take the sample. So it's not E, because bias can include those, but it can also include the person asking. The correct choice here is D. It's just a difference that tends to occur when you use this one specific sampling method. So think of this as when, if I want to figure out if students think lunch is good and I only ask seniors who leave for lunch, they might not know. Or if I want to do a survey about waking up early in the morning and I ask the first few kids who come early in the morning, they're more likely to wake up early than the kids who come to class late. My next question is, you wonder if TV ads are more effective when they are longer or repeated more often or both? So you design an experiment. You prepare a 30-second and 60-second ads for a camera. Your subjects all watch the same TV program, but you assign them at random to 4 groups. One group sees the 30-second ad once during the program. Another sees it 3 times. The third group sees the 60-second ad once, and the last group sees the 60-second ad 3 times. You ask all subjects how likely they are to buy the camera, because you're selling a camera in this. Which of the following best describes the design of the experiment? A, this is a randomized block design, but not a matched pairs design. B, this is a matched pairs design. C, this is a completely randomized design with 1 explanatory variable factor. D, this is a completely randomized design with 2 explanatory variables factors. Or E, this is a completely randomized design with 4 explanatory variables, which are factors. So, this one, there are 2 ads I'm checking out, and then I have 2 treatments of each ad. So this one has 2 explanatory variables. Next one says, can texting make you healthier? Researchers randomly assigned 700 Australian adults to either receive usual healthcare or usual healthcare plus automated text messages such as, walking is cheap. It can be done almost anywhere. All you need is comfortable shoes and clothing. The group that received the text messages showed a statistically significant increase in physical activity. What is the meaning of statistically significant in this context? A, the results of the study are very important. B, the results of the study should be generalized to all people. C, the difference in physical activity, oops, that's a typo, for the 2 groups should be greater than 0. D, the difference in physical activity for the 2 groups is very large. Or E, the difference in physical activity for the 2 groups is larger than the difference that could be expected to happen by chance alone. This one is my answer. Statistically significant means there's too much of a possibility for this to be related, that it can't just be random chance. Number 11 says, you want to know the opinions of American high school teachers on the issue of establishing a national proficiency test as a prerequisite for graduation from high school. You obtain a list of all high school teachers belonging to the National Educators Association, which is the country's largest teacher union, and mail a survey to a random sample of 2,500 teachers. In all, 1,347 of the teachers return the survey. Of those who respond, 32% say they favor some kind of national proficiency test. Which of the following statements about the situation is true? A, because random sampling was used, we can feel confident that the percent of all American high school teachers would say they favor a national proficiency test is close to 32%. B, we cannot trust these results because the survey was mailed. Only survey results from interviewers are considered valid. C, because over half of those who were mailed the survey actually responded, we can feel fairly confident that the actual percent of all American high school teachers who would say they favor a national proficiency test is close to 32%. D, the results of the survey may be affected by undercoverage and non-response. E, the results of the survey cannot be trusted to volunteer response bias. So it's not a volunteer survey because the people were chosen before they were mailed. It is a random sampling, but that doesn't mean I can extend this to teachers because they weren't randomly broken into groups. B, it's okay that they were mailed surveys. It doesn't matter that they were mailed, so that's not right. C, it doesn't matter that over half of the people responded. I still would need more of all of the teachers in the country to respond to actually say it's close to 32%. D is actually my answer here because teachers who didn't respond might not check their mail, and they might also have different opinions on testing students. So, for example, teachers who think we should test all of our students might be more likely to check their mail. It's hard to say. Number 12 is our first free response question. It says, elephants sometimes damage trees in Africa. It turns out that elephants dislike bees. They recognize beehives in areas where they are common and avoid them. Can this information be used to keep elephants away from trees? Researchers want to design an experiment to answer these questions using 72 acacia trees and 3 treatments: active hives, empty hives, and no hives. So at the very beginning, it tells me 2 different statements. Elephants damage trees, and elephants don't like bees. So they want to see if they can put the bees in the trees to stop them from damaging the trees. A is asking me to identify the experimental units in the experiment. So what am I doing my tests on? My tests are being done on the acacia trees. B is asking why it would be beneficial to include some trees that have no hives. This is so I can use it as a control group. To compare to the active hives and inactive hives. Oops, too far. C is asking you to describe how the researchers could carry out a completely randomized test for this experiment. Include a description of how the treatments should be assigned. So the very first thing I want to do here is number the trees from 01 to 72. And then the next thing I would want to do is use a random number generator. Because I'm doing 3 groups on my trees, I want to break 72 into 3 groups. So really quickly, I'm just going to do 72 divided by 3, which is 24. So I'm going to break these into 24 groups. So I'm going to use a random number generator to pick 24 different digits. And I want to make sure I'm picking 2-digit numbers. Once I select those 24 trees, I need to give them a treatment. So I'm going to make these ones the active trees. Active beehives. Then I'm going to do it again. I get 24 more different 2-digit numbers. So the next 24 different 2-digit numbers. We'll get the empty beehives. Then the last 24 trees will be empty. Okay. Then what we want to do is we want to compare the damage caused to the trees with the beehives, the trees with the trees with active beehives, the trees with empty beehives, and the trees with no beehives. Okay, so next one is Google and Gallup teamed up to survey a random sample of 1,673 U.S. students in grades 7 through 12. One of the questions was, how confident are you that you could learn computer science if you wanted to? Overall, 54% of the students said they were very confident. A wants me to identify the population and the sample. So the population is the entire group that these people are being picked from. This is going to be all U.S. students in the grades 7 through 12. Sample is is who actually ended up being selected. So the 1,673 U.S. students in grades 7 through 12. Oops. So this, on the AP test, you would want to be as specific as possible so it's very clear who you are talking about. B is asking me to explain why it's better to randomly select the students than putting the survey question on a website and inviting students to answer the question. So when I randomly assign people, this reduces bias. And then when I do this, I can also, because I'm randomly selecting the student, I can infer my results to a larger population. And then if I think about this specific instance, kids who like computer science, if they're anything like my husband, they also like being on the computer and using the internet. So only those students might respond. C asks me if I expect that the percent of all students in the U.S. in grades 7 through 12 who would say very confident is exactly 54%. This one is no, because of sampling variability. So it should be close, but not exact. D tells me that the report also broke down the results by gender. For this question, 62% of males and 48% of females said that they were confident. Which of the three estimates, the 54% for everyone, the 62% for males, or the 48% for females, do we expect to be closest to the value they are trying to estimate? Explain our answer. So for this one, it is actually going to be the 54%, because more people were surveyed in this group. Because the 62% is probably about half of them, and the same for the 48%. Ooh, I spilled my phone. So my last question says that many people start their day with a jolt of caffeine from coffee or a soft drink. I do not know who drinks soda first thing in the morning, but that seems so weird. Most experts agree that people who consume large amounts of caffeine each day may suffer from physical withdrawal symptoms if they stop ingesting their usual amounts of caffeine. Researchers recruited 11 volunteers who were caffeine dependent and who were willing to take part in a caffeine withdrawal experiment. The experiment was conducted on two-day periods that occurred 1 week apart. During one of the 2-day periods, each subject was given a capsule containing the amount of caffeine normally ingested by that subject in 1 day. During the other study period, the subjects were given placebos. The order in which each subject received the 2 types of capsules was randomized. Subjects' diets were restricted during each of the study periods. At the end of each 2-day study period, subjects were evaluated using a tapping task in which they were instructed to press a button 200 times as fast as they could. A wants me to identify the explanatory and response variables in this experiment. So my explanatory variable is the treatment given. So either the caffeine or the placebo. Placebo. Then my response variable is the time it takes to complete the tapping task. Because I'm trying to see how fast they can do it. B is asking how blocking was used in the design of this experiment. What is the benefit of blocking in this context? So, it's splitting the volunteers up, or that's not splitting them up, but they will be broken into 2 blocks because they have 2 different weeks they're doing this study for. So they're testing 2 different things on each individual. Usually when you have groups of 2, this is a matched pairs design. So think back to the deodorant problem we did in class the other day. You have 2 armpits. This one, you have 2 different trials. Then I just need to go ahead and explain what the different trials are. So each participant will take the caffeine tablets on one of the 2-day sessions and the placebo on the other. Okay. The reason we're doing blocking is I don't know who is naturally faster at tapping than others. So this is why we're doing blocking. C says that researchers randomized the order of the treatment to avoid confounding. Explain how confounding might occur if the researchers gave all subjects the placebo first and the caffeine second. In this context, what problem does confounding cause? So, if I gave them the placebo first, they might know that they're going to have the tapping test the second time and practice to be faster. So if this happened and everyone got caffeine the second time, the researchers wouldn't know if it was the caffeine or the subjects going home and practicing. D is asking me if I could have done this in a double-blind manner. So right now it's single-blind because only the participants don't know what's happening. But double-blind would mean also the researchers, not the researchers, the people who are in the room with them recording their answers might also not know. So this would be fine. If neither people knew, then they wouldn't know the order of the pills.